Imagine you're trying to find your way out of a giant maze. A normal computer would try one path, hit a dead end, come back, try another path, and keep going until it finds the exit. A quantum computer looks at that process and says, why don't I try a whole bunch of paths at the same time? That, in a nutshell, is why people are so excited about quantum computing. To understand quantum computers, we first need to talk about how normal computers work. Every device you use today, your phone, laptop, gaming console, or smart TV, runs on bits. A bit is incredibly simple. It can be either a 0 or a 1. Think of it like a light switch. It's either off or on. Everything your computer does, videos, games, music, photos, is ultimately built from billions of these tiny zeros and ones. Quantum computers use something different called a qubit. A qubit can be 0, 1, or a mixture of both at the same time. This strange property is called superposition. If a normal bit is like a coin lying flat on a table showing either heads or tails, a qubit is like a spinning coin. While it's spinning, it's not just heads or tails, it's kind of both. But superposition allows them to represent many possibilities simultaneously, which can make certain calculations dramatically faster. And that's only the first weird thing. The second is called entanglement. This happens when two qubits become linked in such a way that the state of one is connected to the state of the other, even when they're separated. When Albert Einstein heard about this idea, he famously called it spooky action at a distance. By combining superposition and entanglement, quantum computers can process information in ways that classical computers simply can't. So why does this matter? Because some problems are unbelievably difficult for ordinary computers. For example, finding the optimal route among millions of possibilities, simulating molecules for drug discovery, designing advanced materials, optimizing supply chains, or breaking down incredibly complex mathematical problems. A quantum computer could potentially solve some of these tasks far more efficiently than today's most powerful supercomputers. One famous example involves cryptography. Much of modern internet security relies on mathematical problems that are extremely difficult for classical computers to solve. A sufficiently powerful quantum computer could potentially crack some of these encryption systems, which sounds terrifying. The good news is that researchers are already developing quantum-resistant encryption to prepare for that future. Now here's the part that surprises most people. Quantum computers are not replacements for regular computers. You won't be buying a quantum gaming PC anytime soon. A quantum computer is terrible at many everyday tasks. Using a quantum computer for that would be like using a rocket ship to go next door. Quantum computers are specialized tools designed for specialized problems. Another challenge is that qubits are extremely delicate. Tiny vibrations, stray electromagnetic signals, or even slight temperature changes can introduce errors. That's why many quantum computers operate at temperatures colder than outer space, just fractions of a degree above absolute zero. Today, companies like IBM, Google, Microsoft, and Amazon are racing to build larger and more reliable quantum machines. Researchers have already achieved important milestones, but truly large-scale fault-tolerant quantum computers are still a work in progress. We're essentially in the early days of quantum computing, the equivalent of computers back when an entire room was needed just to perform calculations that your smartphone now handles effortlessly.